Our lesson today is on solving 1- and 2-step equations. Let's take a look at our notes today. You'll see we have expressions versus equations. We have some circles there. These are called Venn diagrams. It's a way to organize characteristics of certain things. So here we're characterizing our expressions in this circle and equations in this one. So expressions, if you remember, have no equal sign. They cannot be solved. We use the words evaluate when we're working on problems that are expressions. Evaluate, use the order of operations. For equations, equations have equal signs. They can be solved, and the directions for those will be go ahead and solve them. In the center, we have some characteristics that they both share. They both have numbers, operations, and variables. When solving equations, your goal is to get the variable terms on one side of the equation sign. Get the constant terms on the other side. We're going to use inverse operations. Inverse meaning the opposite. Inverse operations. To move terms across the equal sign. What do you do to one side of your equation? You must do to both sides. So if we add something on one side of the equation, we have to add that same amount to the other side. Let's take a look at some of our one-step equations here. Addition and subtraction examples. We have m plus 17 equals 22. Some of us like to draw a line down the equal sign to show our two separate expressions. And we want to get the variable all by itself. We want that variable to stay on the left side. So we're going to do the inverse of adding 17. The inverse of adding 17 is subtracting 17. So we do that on both sides of the equation. On the left side, our 17s are opposite or inverse. They cancel each other out. We're down to m equals 22 minus 17. I think that's 5. I don't know that if that's right, though, so I'm going to go ahead and check my solution. We learned how to check in our last unit. Checking means we take our answer and plug it back in for the variable. So I'm going to do 5 plus 17. It should equal 22. And remember, we go ahead and do this evaluating. We say, okay, 5 plus 17, yep, that's 22. It equals 22. Super. That means my answer here of m equals 5 is correct. Take a look at the next one. Again, same thing, line down the equal sign. I'm going to subtract 29 on both sides. I have g equals, because my 29 and negative 21 are inverse operations. And I think we get 26 here. Again, we check it. We take 26. We add it with 29 and see if we get 55 there. 9 and 6 is 15. Carry the 1. Dot, dot, dot. I think we do get 55. It's important to show your steps for your equation as well as your solution and checking. You want to definitely check. Maybe not so much on these simple one-step equations, but as we get into more complicated operations, we want to go ahead and do that. We'll take a look at some subtraction ones. If you want to pause the video and keep working, you can. Try it on your own. If we're subtracting, the opposite of subtracting is adding. And we want to check always. It's always a good idea to circle or box your final answer to a solution. Right here I have my variable on the right side. That's okay. I can leave it there. I still want to get rid of that minus 22. The opposite of minus 22 is to plus 22. So my y will be on the right side. Negative 13, plus 22 will be a positive 9. I definitely want to check that. And at this point, you can certainly use your calculator to check on those integers. All right, this next one is complicated because there's two negative signs, or a minus and negative. So whenever I see double signs next to each other, I want to rewrite my problem and rewrite it using keep, change, change, or keep, flip, change, which means I keep the first integer, I change the subtraction to addition, and I change the second integer to its opposite. Now I have equations that look like sum from above. I'm going to subtract 10 on both sides and get an answer of 2. Make sure if you do this, you always want to double check by putting it back into the original equation, like so. Again, we'll do some keep, change, change here. So we'll have 2 plus 10 should equal 12, and it does. Go ahead and try that last one. Pause the video and try it yourself. All right. We'll look at some multiplication and division problems as well. If there's multiplication in my problem, I want to undo by doing division. So here I have 12 times x. I'm going to go ahead and divide by 12 on both sides. And I'll get my x equal to 4. And I double check. And it works out nicely. Next one, again, I'm still multiplying. I'm going to go ahead and divide by negative 8. Include that minus sign, or that negative sign, with you as you're dividing. And remember, a positive divided by a negative will give you a negative value. When we check, make sure you plug in that negative 9. 2 negatives multiplied give us a positive. We're on to our second side of notes here, if you're following along with me. When you divide by a fraction, you are multiplying by the reciprocal. You might want to follow keep, change, flip on this. So I have p divided by 5. Well, the reciprocal of dividing by 5 is to multiply by 5. So I'm going to go ahead and do that on both sides. It's really multiplying by 5 over 1. But is that over 1 necessary? Not really. So whether you write it there or not, that's up to you. It's going to become necessary in a minute, but for right now, we can just go with this. Our 5s are reciprocal, so they cancel each other out. We have p equals negative times a positive is a negative, like so. When we check, we're checking again that our solution is true before we move on. Now here I have the fraction out in front of my variable. So here I'm going to definitely multiply by the reciprocal, 5 over 1. And you'll see that your reciprocals cancel each other out, so you're left with your variable. And again, do I need to have that the denominator of 1 here? No, because 1 times 1 is 1, we know that. Negative 7 times 5 is negative 35. When I go ahead and check, I'm going to get 1/5 of negative 35, and I'm going to put that as a fraction. It should equal negative 7. 1 times 35, negative 35 is negative 35. 5 times 1 is 5. When we divide, we do get negative 7. So we're correct in our answer. Try that one again. Look at this one. I've got a negative sign out in front of my fraction. You're going to pop that on the top and maybe put a little 1 in there. So it's really negative 1/6 m. So we're going to multiply by the reciprocal of that. The reciprocal of that is going to be negative 6 over 1. By negative 6 cancel each other out. That 1 cancels each other out. I'm going to get m equals 8 times negative 6. And remember, we're multiplying with a negative here to a positive. Go ahead and take a look at that one. We should get a negative 48, and we'll have to check it. So if you remember what your original problem was, I'm going to erase a little bit over here so I can see it. I'm going to have to plug in negative 48 over 6. A negative times a negative, those two negatives cancel each other out here. And we're left with positive 48 over 6, which equals 8, which is the same as this side. See if you can try that last one on your own. We'll take a look at some two-step equations. For two-step equations, we have two operations. Both have to be done to both sides of the equations. We have to isolate our variable first. So we're going to undo any addition or subtraction first. So we have two-step equations next, which means we have two operations. And we're going to have to undo the addition or subtraction first before we can undo the multiplication or division. So here we're going to subtract 17 on both sides. And we'll do that step first. So we have 35 minus 17, which is 18, equals 2x. Then we go ahead and divide by 2. And we'll get our x to equal 9. We definitely want to check our work here as we're getting into more steps. This is where we're going to see if we've made a mistake here. Order of operations, 2 times 9 is 18, added to 17 should equal 35. Double checking our math, it does excellent. Next one, go ahead and try that. We've got two more to try, and these have distribution in them. You've got two different ways to do this, so we're going to take a look at the first question and just do it twice. Divide both sides by the number on the outside. So we're going to go ahead and divide both sides by 2. We'll get 3x minus 5 equals 4. And now we have a two-step equation. Add 5. And then divide by 3. That's one way to go about it. Or you can distribute. So take the outside number and multiply. 2 times 3 is 6x. 2 times negative 5 is 10. And then solve a two-step equation. Either way, we get the same answer. Go ahead and you try both of the last two as I work them out myself. I'm going to go ahead and divide by negative 2 here. And I'm going to try and show you the last one as well here. I'm going to go ahead and multiply by the reciprocal of that fraction. That's going to get rid of that fractional coefficient. So I'm going to multiply by 2. And I no longer have those parentheses. And I can solve a two-step equation this way. Oops, I wrote down 12 instead of 16. We also have applications that are word problems. The chef at Ritzy Restaurant gets paid $35 an hour. So that could be represented as 35x or 35 times x. And he can earn a bonus plus that bonus of $300. If the chef earned the bonus and his check for the week, and it was $1,780.